In this notebook, I'm presenting an in-class exercise that we did in part of a previous class where we download a CSV file that contains information about all the NIH grants, extramural grants, funded in 2015. And this is a CSV tabular data, and we're going to convert this data, or at least a subset of the data, into a relational database. No claims that the relational database design is optimal, but this gives us an opportunity to kind of step through and think through the process of which we might normalize data that we have. Okay, first off, we need to import some packages. The file that we get from the NIH is in a zip file, so we're going to use the Python library zip file. We're also going to just directly read it from over the web with the URL lib library. And in order to get our file reading right, we're going to use the bytes.io, which is going to take a byte string, and convert it into a file-like object that we can read from. So with that, so the location of the file that we're going to read is here, and we're going to use the pandas file, pandas read CSV function to read it in. In order to get it to decode properly, instead of using a UTF-8, I use a Latin 1 encoding, and this is going to take us a little bit of time to read it. So I'm going to pause. Okay, so we now have our file read in, and what we want to look at is a couple of things, but mostly we want to see what our data looks like. But first off, maybe I'll get what the size of it is. So if we do NIH data.shape, so we read in approximately 73,000 rows. And each one of those rows will represent a particular grant that's been awarded. And there's 46 columns describing the data. So what does a particular row look like? Here we can use the iloc method to look at the first row in our data frame. And we have a variety of columns here: application ID, activity, etc. Things that we're going to look at are things like organizational department and organizational state, PI names, direct, total cost, etc. And that title. I don't know where the title is, but we'll find that in a second. Okay, so we could get at the column names just with the pandas columns attribute. And here's a list of all our columns. So we can look at NIH data, look at a few more items here, and with that many columns, it's kind of hard to see what we're interested in. And so, one thing that we're going to run across is the how they represent the principal investigators in this table. So I'm just going to look at that series. And one important thing we're going to see is that we've got multiple, some of these, like right here, we got Robert Schwartz and Maxine Stitzer. And so within a single column, we've got multiple entries. And so we can already tell that this isn't going to be the first normal form that we're interested in. Okay, so let's get down to designing a database. So what we're going to put in this database are the PI names, the organization name, for example, the University of Utah, the organization department, for example, radiology, what the total cost of the grant is, and I think I actually didn't, for the sake of time, we didn't do the type of grant, but we have the project title. And so this is the data we want to store in our database. And so one thing we need to think through is what would be the tables that we would create in our database, and what would the data types be. Well, I'm going to go ahead and we're going to make this in SQLite, and I'm just going to make a database in memory. And so I can do that with this, providing the database name of :memory:, and DB is going to be the variable that stores our connection, and then I'm going to create a cursor from that. Okay, so let's start off by creating a table for our project. And so here's the query that I'm going to use to create it. So I'm going to have the project title, which is going to be of type text. I'm going to have a principal investigator, which is going to be a type int. And that's because instead of storing the name of the principal investigator in this table, I'm going to have this be a foreign key to a separate table where we keep a list of all our principal investigators. And similarly for the organization and the department, these will all be integers that are referring to the unique identifiers, in this case the row IDs, of that particular organization in the organization table and that department name in the table of departments. And finally we'll have the total cost, which will be stored as a float. So if I execute this query, this will create the table. And I need to do similar things for the other variables that we're going to keep. So I need a table where I'll keep the PI names, and a table where I'll keep the names of the organizations, and a table where I keep the names of the departments. So let me just execute each of these. Okay, so now we need to populate our tables. And what I'm going to do for this is just take each of these columns from our data frame, so organization name, PI names, and organization department. I'm going to drop any missing values, and then I'm going to use the unique method of that series to create a series, a list, of all the unique values that occurred in that data frame. And so as we go through this, we'll see we've got 47,000, 48,000 PI names, strings, about 3,600 organizations, and about 64 different department names. Okay, so now we need to insert these into our various tables. And so I'm going to take each one of these organizations, and I'm going to create a list of tuples. You see each tuple is a single element, so I need this trailing comma. And then I'll use the execute many to, what execute many will do is for every entry in this list of arguments, it will execute this query right here. And so I'm going to insert into organization the values that particular organization. So let's execute this. And then we can look at what we put into it. If we just fetch 5 of these, see we've inserted Cornell University's, VA, Palo Alto Healthcare, Ohio State, etc. Okay, so that looks good. If we were to actually look at this, and let's see, so what this query didn't do is it didn't return our row ID, which is going to be our unique identifier. So let's see, what did I call it when I created this? Organization name. And now this query is returning the unique identifier, which is the row ID, and the name that I created for each one of those. Okay, so organization looks good. Let's repeat the process for our PIs, where we'll now, again, we're going to create this, use this list comprehension to create a list of arguments, single tuple, which is going to be the PI name that is going to be inserted into the PI table. And similarly for departments. Now let's see what this looks like. I'm going to do a few more of these. So this is what we insert into our PI table. So we got Christopher Hernandez, John Ashford. Those all look good, but then you see we also have these strings with multiple PIs, and then a PI that's a contact. And so we'll address this later in our notebook. Okay, so now we need to populate the project database. And this is going to be a little more complicated than our previous ones, because for each row of our data frame that we're going to iterate over, which will give us a name, a string which is a name of the PIs, a string which is the name of the organization, a string which is the name of the department. And we're going to want to convert those strings into the integers that are the unique identifiers for that particular string in our organization and our PI and our department databases. So what that tells us is that every time we run across a PI name, we're going to need to do a query. And what we want is the row ID that corresponds to that name in our PI database. And we want to make sure that we do let the SQLite do the interpolation for us. And so we're going to use this syntax where we use the Q mark, our question mark, which is our symbol for SQLite. It's different for different databases. And so if we go through this, then I'm just going to print the PI, what that name was, and then what is the row ID, or the unique identifier, for each one of those entries in our PI database. All right, so now we know how to get the row IDs, which are going to be our unique identifiers, and let's put it all together. So here's how I'm going to populate our project database. So I'm going to iterate over every row in our data frame. I'm going to fill missing values with an empty string. And I'm going to pull out from each row the project title, the total cost, the PI name, the organization name, and the department name. Now so I got these strings. Now I need the integers, the row IDs, which I'm going to insert into the project database as foreign keys. So I start off with the PI names. I execute this query, and I'm going to just grab the first, the fetch one. It's going to return one result, but it is going to be wrapped in a list, or a tuple, so I need to grab the 0th element of that. If it fails, then I'm going to set the PI to none. Otherwise, I'll have an integer value here. I do the same thing for my organization and my department. And what I'm going to ask here is if I was able to get a valid foreign key, unique identifier for the PI, the organization, and the department, then I'm going to insert all these values into my database. So let me run this. Again, this will take a little bit of time, so I'm going to pause the recording to let it run. Okay, and we are back after a long process. So we now have a populated database, and here I was just doing some debugging, seeing what my last row looked like. But now what we want to do is say, well, hey, what does our final table look like? I'm using a combination of Python and SQL here. Most of the stuff that I know that I'm doing with Python, I could, if I was more SQL savvy, answer these questions directly with SQL. But let's see how big our database is. So we ended up with just under 41,000 rows of entries. That is quite a bit smaller than our, let's see, just trying to see if we had our projects. Well, let's not worry about that for now. So let's see what some of our entries look like. So if I look at the first 5 rows in our project, we got this title. We have an integer, which is a foreign key. These are foreign keys referencing our PIs, our organization, our departments. And then we have a total cost of, looks like $203,000. So that's what project looks like. So if we want to get something that's more readable, we need to do a join to put things back together. And so we need to take these foreign keys, these integers that are referring to elements of our PI, our organization, and our department, and do join so we get the values from those tables. And to get, if we do that, so here I'm going to select the project title, cost, the name, the PI name, the organization name, and the department name, and that's going to be based on doing inner joins between project, PI, organization, and department. And so what does this look like? So this is looking a little more like what we want. It looks a little more like what we started with. But we have been able to reduce data redundancy and have more of a database representation of our data than just this tabular data. The question is our solution in first normal form? And that's no, because we have multiple persons in each in entries of our PI name. And so I'm going to stop this video and start a new one where we go through, well, what is one possible approach we could take to getting our data into first normal form.